In this math counts preparation lesson, we are going to be talking some more number theory. I have two problems. We're going to be focusing on the problems. Before we focus on the problems, we are going to be talking about some prime factorization. Right, now prime factorization is, we know that every single integer which is greater than 2, I believe, can be broken down into a product of primes, right? Every single integer, and every single composite integer. So let's say I have something like 15. The way I break this up into a product of primes is 5 and 3. If I have something like 16, I can break this up into a 4 and a 4. And I can break up each 4 into 2's. And then I can express the prime factorization of 16 as 2 to the 4th power. And prime factorization also helps us figure out divisibility rules. For example, the divisibility rule for 6 uses the prime factorization of 6, 2 times 3. If you don't believe me, go ahead and try it out, a similar thing for something like 12. 6 and 2. Over here we have 3 and 2. 3 times 2 times 2. 3 times 2 squared. Compute the exponents first. We get 3 times 4, which matches the divisibility rule for 12. Divisible by 3 and 4. So, obviously, prime factorization is one of the most useful techniques and most powerful techniques in number theory problems, especially in math counts. A lot of them are just prime factorization problems in disguise. So, we're going to start right here. If p is prime and n is even such that p plus n is 47 and the product of pn is 210, where's the value of n? Okay, so the pn is a product and p is prime. Well, I'm first going to take the prime factorization of 210. This is 35 and 2. This is 7 times 5. And, well, no exponents. We have 7 times 5 times 2 times 3. Now, we know Pn, I'm going to write everything we know, is 47. P is prime, and the product Pn is 210. We could just go ahead and guess and check, but that would take forever. We have a better technique right here. We have the prime factorization of 210. Now, we want to build an even and a prime using this. So first let's try to build an even. Well, 14, that's too small. We're going to try to build an even. Well, first we need to multiply 3 numbers and then find some sort of other thing. So if I multiply, let's say I'm going to multiply my numbers to get an even and then leave out a prime. We have, all of these are prime, but we're going to build even. So 7 times 5 is 35. 35 and 2 is 70. 70 is not. We have 70 and 3, but they don't sum to 47. Invalid. We can have 6. 5 is nope. 30 and 7, same problem. The sum is not 47. 10 off. Getting close. 5 times 2 is 10. 70, nope. That brings us back to where we were. 2 times 3 is 6. 6 times 7 is 42. 42 times 5. The product equals 210. And 42 plus 5 is 47. Check it out. 42 is even. 5 is prime. So now we have P is 5, N is 42. We have a product over here. And that equals 210. You can also say that 5 plus 42 equals 47 because it just does. So we have this information. What is the value of n? N is the even number, so n is equal to 42. Prime factorization helps a lot. Okay, this one is from same thing, 2017 Math Count School Sprint, number 28. So it's one of the harder questions on the test. All credit goes to Math Counts again. Sasha's secret passcode is a 9-digit number that begins and ends with 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Very long number. We don't want to guess here. The sum of every 3 consecutive numbers. Okay, first let's just label everything. Whenever we have a number theory problem in which we're asked to find some number, label everything using this. So sum of every 3 consecutive numbers is 14. Okay, so basically this plus this plus this is 14, and this plus this plus this is 14. So we just move like this. These 3 have to add to 14, and we start from here. These 3 have to add to 14. So every pair, essentially, these 3, then we start from here, and these 3, and these 3, then we start from here, and these we start from here, right? And then these 3, then we start from here, and these 3 start from here, these 3 start from here, these 3. So that's what we're aiming over here. Now, can erase that now that you understand the problem a little bit. Let's go ahead and do that. We're going to do exactly what the problem says. We're going to construct, we're using some constructive number theory, a possible thing, and we're going to go until we reach a possible case. Now, there's not a lot of numbers like this, so we only have to test like 2 or 3 cases, which is doable. The sum of every 3 consecutive numbers. Okay, so we have 6 already, so 14 minus 6 is 8. That means these two have to sum to 8. When I think of 8, I think we're going to go 2 and 6. 2 and 6. And now we go 2, 6 is 8. 8 plus 6 is 14. This has to be a 6. Now 6 plus 6 is 12. 12 plus 2 is 14. This has to be a 2. 6 plus 2 is 8. 8 plus 6 is 14. This has to be a 6. 2 plus 6 is 8. 2 plus 6 is 8. 8 plus 6 is 14. 6 plus 6 is 12. 12 plus 2 is 14. And the last pair, 6 plus 2 is 8. 8 plus 6 is 14. This satisfies it. If we take a look at all 3 consecutive ones, we have 6, 2, and 6. 8, 14. 12, 2, 14. 12, 2, 14. 8, 6, 14. 8, 6, 14. 8, 6, 14. Interesting. Now, what if we altered this a bit? What if we picked 6? What if we picked the same thing? 1, 2, 3, 4, 5, 6, 7, 8, 9. What if you reverse the 6 and the 2? 12 plus 2 is 6 plus 6 is 12. 12 plus 2 is 14. 6 plus 2 is 8. 8 plus 6 is 14. 2 plus 6 is 8. 8 plus 6 is 14. 6 plus 6 is 12. 12 plus 2 is 14. 6 plus 2 is 8. 8 plus 6 is 14. And now we have 2 plus 6 is 8. 8 plus 8 over here. 6. 8, 6, 12, 2. But now we have this, which is invalid. And this is the only one. 6 plus 2 is 8. 8 plus 6 is 14. Other ones all obviously satisfy it. So we want the 5th digit of the passcode. Well, this is the 1st digit, 2nd, 3rd, 4th, 5th. So the 5th digit is just 2. If we're being honest here, this was one of the easiest problems on the final page of the school sprint, and probably one of the easiest, like, top 2 hardest problems in math counts that I have seen in the school sprint round competition. But overall, it was an interesting problem. We used some guess and check, so we checked if that worked, if you reverse the digits. Always make sure to check there's no other cases, because if this was another case, then we probably did something wrong in our addition or something. But yeah. Alright, hopefully this video is helpful.